It's what's called transversals intersecting three parallel lines. Now, what you have here is, in all these questions, you're going to pretty much have three lines. Okay? The three lines are always going to be equally spaced. Okay? So these three lines are equally spaced. These are your three parallel lines. Okay? Now the next part is, they cut off equal segments of some transversal. Then they will cut off equal segments of any other transversal. So here's what it means, right? They give you three parallel lines which are in the green. Okay? They draw what's called a transversal. A transversal is a line that doesn't change direction. So what I mean is, it doesn't do this. Okay? And what it will do is, it will just go all the way down, and it will cut all three lines. Now what it says in the theorem is, it says it cuts off equal segments. Equal segments means from here to here, we can give them any letters we want. M to N is the same distance as N to O. So an example would be something like this, guys. If I said AB is 5, what can you tell me about BC? 5 as well. This one might be a bit shorter because it's going, see the way it's a steeper slope? That means that it's not going to be as big.
Is that not what the line means?
Yeah, it means they're the same length as each other. Yeah. Okay, so, but see the way this one has 2 slashes in it and this one has 3. That means that they're actually not the same length, so only this one is the same one. So what's this one down here? 4. Alright, that's it. Okay? That's basically this theorem in a nutshell. So we basically go to the next question here, okay? Question 4. Now, question 4, alright? What question 4 is doing to us is this. The transversal F and the transversal T. And it says in the description of the questions that these are just equally distant from each other, okay? Now, what I want us to do here is, we know that 2A is the same length as 8, yeah? So Keane, we can write down the formula. 2A equals 8, A equals 4. Once we know that this A equals 4, what can we say about 3A? 3A is 12. And 12 is the same length as? 6B. Exactly. So 6B equals 12. B therefore equals 2. That's what they're looking for you to do in this exercise, okay? Excuse me. Okay. Next one, alright? This is considered the most difficult question in this one. Okay? Now, L, M and N are parallel lines, which means that they do what we're talking about in the theorem, okay? They cut equal intercepts on the line P. The line P is here, so that means x, y equals y, z. Okay, describe the line P. The line P, it says describe the line P. Okay, so what we can just say is the line P, I know it's an unusual question, right? Just do whatever. The line P is, I reckon it's parallel to the y-axis because it's going to be like going straight down, isn't it? So it's parallel to the y-axis. And it's a transversal. It's a transversal line. Do you know what I mean by transversal line? It's a line that goes through all three lines L, M and M to L, M and N. Okay guys, is P perpendicular to M? Explain your answer. Okay? Okay, the next one is P perpendicular to M? Okay? Is P perpendicular to the line M? It is perpendicular to the line M because P is perpendicular to the line L. P is perpendicular to L. And L is parallel to M. This means that P has to be perpendicular to M. Do you understand what I mean there? It shows that P, which is this line here, is perpendicular to L through this sign here. And because M goes in exactly the same direction as L, it also has to be perpendicular to the line M and the line n. Okay, next part. xz is 20. Calculate yz. Okay, so xz is going to be this part here. From here to here is 20. What do you think yz has to be? Because both of them have to be equal. Okay, if xz plus db, xz is 20 plus db, xz plus db is 44. What does that mean about db on its own?
24.
It's going to be 44 minus 20, which is 24. Shh, excuse me. It's 24 from here to here. What is half going to be? What's FB going to be? 12. What's DF going to be? 12 as well. Okay, if FG is 30, so F to G, I'm seeing it here, F to G is here. F to G is 30. Okay, and FB is parallel to GH. Now where's FB located? It's parallel to GH. Okay, calculate the area of the parallelogram BFGH. So I'm just going to zone in on that now. Okay, shh, lads, BFGH. Okay, just zone in on it here. It's going to be here to here, here and here. Now guys, what do we need to calculate the area of a parallelogram?
The base and the vertical height.
We need the vertical height. Do we actually have the vertical height?
Yeah, we have a 10 there.
It's 10.
It's not 12.
No, 12 is the slant height. The vertical height is 10. Yeah. Now guys, shh, parallelogram is base by height, which is going to be 10 by 30, which is 300 centimeters squared. Now, hence calculate the distance between the parallel lines FB and GH. Okay, FB and G to H. Okay, now FB and G to H is actually still 30, isn't it? Because it's the same length as FG. Do you see that? G to H is this line here in blue, and FB is this line in blue. And we know that the base of the parallelogram is 30. So that means there's got to be a distance of 30 between them. Okay, so it's 30. Okay? Alright lads, in class